Good afternoon, everybody. I'm Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum in Philadelphia, Pennsylvania. I'm standing at the Franklin Institute's rooftop observatory, fourth floor of the building, and behind me you can see part of the great Zeiss refractor, refractor that we use here at the Franklin Institute every day the sky is clear to give folks a really great view of the sun, with the proper filters, of course. And we also use this telescope for our regular monthly program, Night Skies at the Observatory, in which we invite visitors to come take a look through this telescope at what's available to be seen in the night sky in a center city environment. Actually, quite a bit more than you might expect can be seen, and it's a real party that we have here going on those nights. Second Thursday night of every month. If you're in this area, we invite you to come down and check us out. If you happen to be in Philadelphia on the second Thursday night of any month, we invite you to stop by and see what we have going on here. It's a lot of fun. You'll learn a lot about astronomy, space science, and we have great speakers and all that sort of stuff. The reason why I'm joining you today is to talk a little bit about one of NASA's premier space explorers. No, it's not a person, it's actually a satellite. It's the Cassini spacecraft that has been orbiting Saturn for about 20 years now. And that spacecraft is entering the final phases of its mission to bring us information about Saturn and all of its, or many of its moons, as we can gather information about. The Cassini spacecraft stands about 22 feet tall. It's a fairly large affair, weighs a little over 4,000 pounds, and that should be 4,000 kilos, I'm sorry, and it is really a very, very heavy spacecraft, very large spacecraft, very, very capable. And it's been doing all sorts of really great work since it left Earth in 1997. On its long cruise out to Saturn, it slept most of the way, arriving at Saturn in 2004. And one of the very first things that happened when the spacecraft arrived at Saturn was it dropped off, actually, a smaller craft that landed on Saturn's largest moon. That is Titan. I remember this as an iconic piece of this mission because, you know, it's one thing to send a spacecraft out to orbit around planets, take a lot of pictures, gather a lot of science data, things like that, but to actually have another secondary spacecraft riding sort of piggyback, if you will, during the long trip out there, and then have it wake up and be able to perform its mission after having been asleep for so long is really a remarkable thing, and I remember when that happened. We got photographs back from that spacecraft that landed on the surface of Titan showing us what that moon looked like. Very first time we'd ever had photos of another moon orbiting another planet, and you can go check those images out, of course, at nasa.gov, where you can find those images. That was the spacecraft that landed right down on the surface of that giant moon Titan. We'll talk a little bit more about that in a few minutes. But today is a very special day. It's a special day because just this morning at 2 a.m., the Cassini spacecraft began its last 22 orbits orbiting Saturn as part of its demise at the end of its mission life. So that first one started this morning. It's an unusual orbit that it's taking around Saturn because what's actually happening now is the orbit is a fairly large open loop that brings the spacecraft really close to the cloud tops of Saturn by flying in between the ring system of Saturn and the upper atmosphere of the planet itself. So there's a gap right in between, and the spacecraft is coming right inside what's called the D ring of Saturn, and it loops down and around the planet and goes back out to a good distance away, and then loops back around once a week from now until September 15th. So during that time, the spacecraft has an opportunity to not only get really good close-up images of Saturn, but to also be able to get really, really good data about the atmosphere of Saturn, because it will get fairly close, within 1,000 miles or so of the upper cloud tops of the planet, and that will give the spacecraft a chance to collect a lot of data. In fact, in some instances, it's just going to skim the surface of Saturn, the upper atmosphere of Saturn, I should say, and then head back out on its long looping orbits. So these 22 orbits will mark the last of its journey, and at the end of its journey, on the 15th, what's going to happen is the spacecraft is going to plunge into the atmosphere of Saturn, where it will be destroyed. Now, a number of people are asking the question, well, why would you want to deorbit the spacecraft right into Saturn? And mostly the reason why is because scientists and engineers really want to make sure that they can dispose of this spacecraft by completely destroying it, incinerating and crushing it, just completely wiping it out in this planet's atmosphere, in hopes that doing it this way will avoid contaminating any of the other moons of Saturn. Now, Saturn has more than 60 moons, and some of those moons actually look like they could be candidates as places where there's an environment where life could or could have possibly developed at some time in the past. Now, as of today, we have no indication at all that there's any life form out at Saturn or at any of its moons. But scientists and engineers don't want to take any chances by contaminating any of those moons with any kind of microbes that might come from Earth. So the best way to try to get rid of any of that stuff, any of that contamination, is plunge it right into Saturn where it'll be completely destroyed. So we'll talk a little bit about those moons also as we talk a bit further here. So that first orbit, that first of the last 22 began this morning, will happen once a week until we get out to the end of this. So the spacecraft has actually discovered a tremendous amount about Saturn, understanding the magnetic fields of Saturn, understanding what the atmosphere is like, and particularly looking at the really dynamic atmosphere of Saturn, where all kinds of really great things have been discovered. So for example, did you know that Saturn is a planet that has its own aurora? You may not have known that, but yes, it does. Right at the north and the south poles, it has auroral activity that has been photographed in ultraviolet light by the spacecraft taking a look at the planet. But did you also know that the way the winds work at Saturn, particularly at the poles, you can actually see that there's an interesting hexagonal shape to the clouds right around that polar region. That's extraordinarily unusual and was completely unexpected to be found there. Now, we had some idea, of course, how the clouds, as they circulate the planet, might cause various kinds of eddies and disturbances and all kinds of shapes called festoons, which are really clever, interesting little curly Q shapes that are developed as the clouds are sliding past each other at various velocities. But we had no idea that we'd be able to see a hexagonal shape at the very top of the planet, at the top of the planet's atmosphere. So as we look at the planet and we understand more about its chemical makeup, the hydrogen, methane, ammonia, all those sorts of very light elements that make up the atmosphere, it helps us to understand better how gas giant planets like this and its sort of brother planet, if you will, Jupiter, how planets like this form in a solar system like ours, and how those environments might be conducive to the development of other moons and environments that might have some bearing on life in a solar system. I mean, if you really look at the chemical elements that are found at Saturn, what we're seeing is essentially the basic building blocks of a soup from which perhaps life might develop. Now, if we look at this planet even more closely, what we find is that the likelihood for life to develop at Saturn is actually quite low. And the reason why is because Saturn is very, very far out from the Sun. It's 884 million miles away from the Sun, and the temperature out there is easily 250 to 350 degrees below zero. That's tremendously cold, so certain kinds of reactions can't really take place there because the environment just isn't the right. But just the same, those chemical building blocks for making organic molecules are there. That helps to tell us that as we look around the rest of the galaxy, if we find planets that have this kind of organic chemical element composition, they might be areas where it's possible for life to find an environment where life might be able to develop. You'll notice I use lots of caveats here. Maybe, might, potentially, who knows, we're not really sure. And that's critically important because right now all we're finding are building blocks, just building blocks. So far as we know, Earth is the only planet that has the environment where those building blocks can come together to make up the organic soups that from which life developed on this planet. But it's still tantalizing to think about out there at those distances in the solar system around Saturn. So let's go back to the moons for just a bit, because as we mentioned earlier, that's one of the major jobs that was performed by the Cassini spacecraft while it was out at Saturn, was looking at some of the moons. So we looked at Titan, and one of the things we found out about Titan is that Titan has an atmosphere. It has a methane atmosphere. But when we looked down at the surface of the planet, we also found out that Titan has hydrocarbon lakes. Lakes, can you imagine? Lakes of hydrocarbon materials? Now, we're not talking about petroleum or anything like that, but we're talking about things like methane, in particular methane lakes and methane rivers. And as the spacecraft gave us better and better images of Titan, we were able to discern a couple of really interesting things. So if there's an atmosphere, a methane gas atmosphere, and we also find that there are liquid methane lakes on the surface, we also noticed that there were like stream beds and gullies and channels, stream channels it looked like. So when you put all these things together, what it begins to indicate is that there's some sort of process going on in which the methane gets up into the atmosphere. It can then condense into some sort of a rain or snow that falls onto the surface, that then runs across the surface through these channels and into these large depressions so that it makes lakes. So in a sense, there's some sort of a hydrologic cycle, like we have here on Earth, where water vapor evaporates from large bodies of water like oceans, rises up into the atmosphere where it condenses into clouds. Those clouds then passing over land or any other place might cause their water vapor to condense into rain, and then that rains down onto the surface, runs off the surface, goes back out to the reservoirs, the oceans and lakes, and then goes back up again. So there's that cyclic process. So this is something that's being inferred on Titan because of what we find of these different pieces that give us these different components that lead us to believe that this is a process that's going on there. So there's a lot of that kind of stuff happening out there. Very, very surprising for what's going on out there. So we know it has an atmosphere. We know the atmosphere is affected by the energy it gets from the sun. So even at that distance, the sun is having an effect there. So some of the other moons that are out there are looking like really interesting places because they have icy surfaces with liquid water interiors underneath the icy surface. The moon in particular I'm speaking of it is Enceladus, and Enceladus has surprised us for a couple of reasons. The major one being that we've discovered that it actually has a liquid water ocean underneath its icy crust. That's just stunning. Liquid water found someplace else in the solar system other than here on this planet. So that's compelling for a couple of reasons. Number one, we know why the surface is icy and frozen. It's because it's so cold out there. 300 degrees below zero, it's enough to freeze almost anything. But for the water underneath to be liquid indicates that there's some sort of a process that's allowing water to exist as a liquid, to be above 32 degrees, at 32 or above 32 degrees Fahrenheit, so that the water can remain a liquid. Now in this case, we clearly understand that we're really talking more about some sort of a tidal effect between the moons of Saturn and the gigantic planet itself, in which the planet or the moons are being squeezed and pulled by the gravitational pull of the outer moons and the giant planet itself. So that would generate enough heat to keep the water as a liquid. But the other thing we're discovering is that water seems to be very, very, I shouldn't say heavily laden, but has enough hydrogen in it that the water now appears to be a potential food source for certain kinds of microbes that could exist in an environment like this. Again, note, I'm saying could exist in an environment like this. But that certainly does raise the bar for the possibility, and that's also very enticing, very exciting to think about that. So we've discovered this because the spacecraft itself had an opportunity to sample some of the water inside the moon. Well, you might be asking, how could it do that? Did it land on Enceladus, drill down through the ice and get a sample of the water? No, a very, very different process. As it turns out, Enceladus has vents of water vapor through cracks in the surface ice. And through those vents, those jets spray up off the surface of the moon, and they actually contribute material to the outer ring, the E ring, of the planet Saturn itself. So the spacecraft had an opportunity to fly through some of that, take a sample, and begin to understand that the chemistry of that water indicated that there's enough hydrogen there that it could be a potential food source for certain kinds of microbes. Well, as I said, very exciting news to learn about moons out at that distance. Now that opens the door for us to understand or to look for moons like this orbiting planets, orbiting other stars at other places in the galaxy. So all of this work that's being done to understand what's happening here in our own solar system, not just with the rocky planets, Mercury, Venus, Earth, and Mars, but also with the gas giant planets, Jupiter, Saturn, both with their moons of different types, helps to expand our knowledge base so that as we go exploring around the rest of the galaxy and find all of these other stars that have planets orbiting them, we begin to have sort of like a base model, if you will, that we can use to characterize what these planets and moons must be like. You know, the ultimate goal, some people would say, of us looking around for planets orbiting other stars is to see if we can find an Earth-like planet. We haven't found any real Earth-like planets yet, but just the same, we find lots of different examples of different kinds of planets and different kinds of moons. And we need a way to put these all into a system to help us understand what the possibilities are for what we might find out there in our galaxy and truly across the rest of the universe. So the work that the Cassini spacecraft has done over the last 20 years has really helped us understand what gas giant planets are like, what their families of moons are like, and what we can expect to find elsewhere in not only our own solar system, but in other solar systems around the galaxy. So you can keep up with the news about what's happening with Cassini, of course, at nasa.gov. They have all kinds of fantastic information. Not data, well, they also have all this great data about what the environments are like, but what you really have to check out are the photos. The images are just incredible. Up-close views of Saturn that are going to continue to get better over these next 22 orbits as we head towards the final dive on September 15th. But also throughout the entire mission, the photographs of the moons, the photographs of Saturn, the photographs of Earth from Saturn. Oh, there's a great photo I saw just recently that Cassini took looking back to Earth from Saturn's distance out in the gap between the rings and the planet itself. Boy, talk about giving you a good perspective on our little planet here. I think it's a really, really compelling image that we all could learn from if we take a look at that. So plenty of data available at NASA's website about Cassini, plenty of really great pictures that will help you understand what the whole mission has been about, and also set you up for what's going to happen over the summer as we come up to the final demise of the Cassini spacecraft on September 15th. So stay tuned. You'll learn more about that. We'll bring you more here, of course, from Franklin Institute. And don't forget, if you're looking for other information about any kind of science and science programming, check out our website here at www.fi.edu. And of course, you can follow me on Twitter. I'm @CoolAstronomer. Thanks for joining us. We'll catch you again next time. So long.